Chapter 6, Section 2, Right Triangle Trigonometry. Remember SOHCAHTOA back from your good old geometry days? Well, here we have a right triangle. Theta is the angle we're focusing on. It's the one in the right corner. You see the right angle there. We have the opposite side and the adjacent side, which are always relative to theta. They're always relative to the angle we have in question. The opposite is always opposite that angle. The adjacent is always adjacent or connected to that angle. The hypotenuse is always the longest side. It's always the one that is opposite the right angle. It doesn't matter which angle we're talking about for theta, the hypotenuse is always the hypotenuse. And remember these relationships from geometry. The sine of an angle is the opposite side over the hypotenuse. So whatever the opposite side length is over the hypotenuse length. The cosine of an angle is the adjacent side length over the hypotenuse length. And the tangent of an angle is the opposite side length over the adjacent side length. Now we also have reciprocal functions of these. You may not have had these in geometry, although we did talk about them in Algebra 2. We have the cosecant of theta, which is the reciprocal of sine. It is the hypotenuse over the opposite. The secant of theta, which is the reciprocal of cosine, is the hypotenuse over the adjacent. And the cotangent of theta is the reciprocal of tangent and is adjacent over opposite. It is very important that you know these and that you know them well. It is very important that you get straight which reciprocal goes with which trig function. The sooner you learn this, the better it's going to be, the happier you're going to be, and the easier it's going to be. So get these down well if you didn't learn them before. So what you're going to do is you're going to find the exact values of the 6 trigonometric functions of theta. You have a missing side, but use the good old Pythagorean theorem, a squared plus b squared equals c squared, to find the missing side. Pause the recording and give this a try and resume to check your answer. So the hypotenuse is 10. And here we have it. Sine is opposite over hypotenuse, which is 6/10, reduces to 3/5. Cosine is adjacent over hypotenuse, 8/10, which reduces to 4/5. Tangent is opposite over adjacent, 6/8, which is 3/4. And once you have those, you really just need to flip them upside down for cosecant, secant, and cotangent. Now do the same thing. You're going to find for both of these triangles the 6 trigonometric functions of theta, and you're going to find that they're the same. Why do you think that is? Pause the recording, work them out, and resume to check your answer. Okay, so the hypotenuse of the first one was 17, and of the second one, 17/2. And when you put them into the ratios and you simplify, you discover that they do indeed have the same sine, the same cosine, and the same tangent. The reason for this is that these two triangles are similar. Similar triangles have angles that are of the same measure and sides that are in proportion. It's kind of like taking one of the triangles and putting it on a photocopier and setting it to enlarge or to shrink. Everything, the proportions will all stay the same. It's not going to look suddenly distorted. It's just going to be larger or smaller. And since these are ratios, then that's going to mean that they are same for the same measure of angle. Sketch a right triangle corresponding to the trigonometric function. Use the Pythagorean theorem to determine the third side, and then find the other 5 functions. So what you're going to do is draw a right triangle, pick one angle to be theta, and then label the opposite and adjacent side as 3 and 4. Find the hypotenuse, and then write the rest of the trig functions. Pause the recording, give this a try, and resume to check your answer. Okay, see how well you did? Notice what I did was I labeled the opposite side of theta as 3 and the adjacent is 4, and I calculated that the hypotenuse must be 5, and then just put them into the ratios. Okay, this is the same thing. Just secant this time. Pause the recording, give it a try, resume to check your answer. Make sure you put everything where it is. Notice that we left that side as the square root of 5. The reason we did this is we want an exact answer. Getting a decimal doesn't do it. Getting a decimal gives you an approximate answer. You need to get used to dealing with square roots. Notice that the cosecant is 3 square root of 5 over 5. Now you might have written 3 over the square root of 5, which is correct. However, we do need to rationalize the denominator, which means we don't want to leave a square root in the denominator. So we're going to multiply the numerator and denominator both by the square root of 5. That gives us a denominator of 5 and the numerator of 3 square root of 5. Cotangent is the same thing. Now in geometry, you had two special triangles. The first one was 45, 45, 90. If you didn't learn this relationship, the 1, 1 square root of 2 then, it would serve you well to learn it now. You do need to get it down. The two sides will be equal, the two legs, and then the hypotenuse is whatever the leg is times the square root of 2. We have special values for sine, cosine, and tangent for those. If you know the triangle, if you can sketch the triangle, then you can automatically, you can pull up the sine, cosine, tangent. You can get the trig functions off of that. 45-degree angle is pi over 4 in radians. We do need to start thinking in terms of angle, degrees, and radians. So you see here the measurements. The sine is the square root of 2 over 2. Cosine is the same, which makes this easier. The tangent is 1, and then you see the reciprocals. It was a 30, 60, 90 triangle. The side across from 30 is labeled as 1. The hypotenuse is 2. And the side across from the 60-degree angle is the square root of 3. Again, if you can sketch this triangle, if you know this triangle and you can sketch it, then you can easily come up with the sine, cosine, and tangent for 30 and 60. And if you know the sine, cosine, and tangent, then you know the cosecant, secant, and cotangent. For a 30-degree angle, we have pi over 6. And for our 60-degree angles, our radian value is pi over 3. And you see those all listed here. Again, it is going to be to your benefit to be able to sketch these special triangles as we go through trigonometry for the rest of this year. Okay, for this one, you're going to construct the triangles and find the missing values. I suggest you just go ahead and draw the two special triangles and then go along and find what we're looking for here. Pause the recording, give it a try, resume to check your answer. So pi over 4 corresponds to 45 degrees, and you see the triangle there. So once we draw that, the secant is the reciprocal of cosine, and the cosine would be 1 over the square root of 2, so the secant would just be the square root of 2. Looking at a 30, 60, 90 triangle, the function that has a cotangent of square root of 3 over 3 would be 60 degrees. The tangent of 60 is square root of 3. The cotangent is 1 over the square root of 3, which gives us the square root of 3 over 3. And the radian equivalent of 60 degrees is pi over 3. And then finally, cotangent is 1. That corresponds with a 45-degree angle or a pi over 4 radian angle. Okay, note that the sine of an angle is the same as the cosine of its complement. In other words, the sine of the 60-degree angle is the same as the cosine of the 30-degree angle. The sine of a 10-degree angle is the same as the cosine of an 80-degree angle. And that's why these are called cofunctions. In fact, that's what the co represents in the word cosine, in the word cosecant and cotangent. It's shortened form of complement. So for sine and cosine, they are the same for complementary angles. The same is true for secant and cosecant and tangent and cotangent. The cofunctions of complementary angles are always equal. Okay, I got a big warning here. Now we are going into radians and degrees as well. So it's really important to always be aware of what mode your calculator is in. You can switch between degrees and radians in the mode menu of your calculator, so push the mode button. If you don't want to change modes, you can use the symbols in the angles menu. So let's say you're in radian mode and you have to do 1 degree problem. Well, you can put in the angle and then hit second apps and choose degree, and this will override the fact that you are in radian mode. Okay, another warning. Your calculator does not have secant, cosecant, or cotangent buttons. It is really tempting to press the second button and then sine, cosine, or tangent, but that will not give you secant, cosecant, or cotangent. That is something different. Those are the inverse functions. We will get to them later. Do not use that at this time. Instead, what you need to do is remember that these functions are reciprocals of sine, cosine, and tangent. So here's what you will do. You will use the fact that the cosecant is 1 over the sine. So if you need to find the cosecant on your calculator, do 1 divided by sine. Secant, 1 divided by cosine, and cotangent, 1 divided by tangent. This is an alternative way of doing it. You can do the sine and then put that in parentheses and do the -1 power. A -1 power means 1 over, and that'll work as well. Okay, so this is a summary of some identities. We've seen some of these already. The reciprocal identities we've already seen for sine, cosine, and tangent. And secant, cosecant, cotangent. We also have what are called quotient identities. And the quotient identities tell us that the tangent of an angle is sine over cosine, and the cotangent of an angle is cosine over sine. And these are identities you do need to know. We have Pythagorean identities as well. Now, of all the formulas and identities we do for the rest of the year, as far as trig goes, these are the ones you need to know, okay? The rest of the formulas I will give you, but these are kind of basic ones that you need to have, you need to know. These are the same ones that in the college trig, they have to know these. The rest of them are given. These are the ones they need to know, and these are the ones you need to know. The better you know them, the easier other things are going to be. So just kind of look over those. The Pythagorean identities come in very handy later on, and the rest of them are always handy. So make sure you get these down. Oh, by the way, when you're doing the sine squared or cosine squared or something, your calculator doesn't understand this notation that is used in writing, where you have sine squared and then the angle. So what you need to do to actually get the value in your calculator is put the sine of the angle in parentheses and then square it. All right, you're going to try these problems. Use your calculator to evaluate each function, round to 4 decimal places, and make sure you're in the correct mode for what you're trying to do. Pause the recording, give it a try, and resume to check your answer. All right, use the given function values and the trigonometric identities to find the indicated trig functions. And these are all special angles, so you should know these anyway. But what they want you to do here is actually use the fact that tangent is sine over cosine and the reciprocals and all of those. So give this a try, pause the recording, and resume to check your answer. Function value and the trigonometric identities, find the tangent, the cosecant, and the cosine of alpha, given that the cotangent of alpha is 5. Pause the recording, give this a try, and resume to check your answer. So the tangent is just 1 over the cotangent, which is 1/5. No big deal there. We have a theorem, Pythagorean identity, that says that cosecant squared of alpha is 1 plus cotangent squared. So if we use that, we get that cosecant is square root of 26. And we have one that says the secant squared is 1 plus tangent squared. So we find that the secant squared is 26 over 25, or the secant is square root of 26 over 5. The cosine is the reciprocal of that, so flipping it upside down, we get 5 over the square root of 26, and then rationalizing the denominator, 5 square root of 26 over 26. Now use the trigonometric identities to make the left-hand side of the equation look like the right. What you're going to do for these is you're going to start with the left-hand side, and you're going to use the identities to change it until you make it look like the right. So it's kind of like a proof, but not exactly. You don't have to write reasons, and you just want to use the identities you know. Pause the recording, give it a try, and resume to check your answer. So tangent times cotangent, well, the cotangent is 1 over the tangent. So tangent times 1 over tangent is 1. There's several ways you could do this, actually. You could have changed tangent to 1 over cotangent and gotten the same result. So there actually are many approaches to a lot of these types of problems. As long as you use legitimate identities, you're in good shape. Okay, so for the second one, really helpful thing to do here is to multiply the 1 plus sine theta times 1 minus sine theta. And when you multiply it out, it gives you 1 minus sine squared of theta, which is cosine squared of theta. That's one of our Pythagorean identities, or it's a rearrangement of it. And the final one, sine over cosine, what they did was they gave it a common denominator. And that gives us sine squared plus cosine squared over sine cosine, which is 1 over sine times cosine. And 1 over sine is cosecant, 1 over cosine is secant. You see a couple of techniques that we use here, and we're going to do more of these identities later on. But notice that one thing we did was we gave the fraction a common denominator. That's a technique we use a lot. We multiplied two things together. We FOILed them out. We do that a lot. And also just using the identities. Those are just some of the techniques we'll be using. Okay, find the value of theta in degrees and radians without using a calculator. You'll be using your special triangles on this. Pause the recording, give us a try, and resume to check your answer. Okay, some applications. Angle of elevation is defined as the angle from your eye level up to an object, and the angle of depression is the angle from your eye level down to an object. You see an illustration here. The angle is made by your straight line eye level, just straight ahead of you, to the object that you're looking up at or down. So angle of elevation, angle of depression. Notice that the eye lines there are both parallel to each other, which means our angle of elevation, angle of depression for two, in this case, people looking at each other like in this arrangement, are actually going to be the same. And something else we're going to be doing is solving a right triangle. And what that means, when they say solve this right triangle, it means you find all the missing angle and side measurements. You can use the trig functions to do that, use the Pythagorean theorem to do that. So, example, you're standing 45 meters from the base of the Empire State Building. You estimate that the angle of elevation to the top of the 86th floor, which is the observatory, is 82 degrees. The total height of the building is another 123 meters above that. What is the approximate height of the building? One of your friends is on the 86th floor. What is the distance between you and your friend? Okay, I'm going to let you pause and do this, but I strongly suggest you draw a sketch of the situation. So pause the recording, draw your sketch, give it a try, and resume to check your answer. Okay, so here's our sketch. Not very exciting, but we're 45 meters away. We have an 82-degree angle, and the top of the X is our 86th floor. Y is going to be the distance from us to our friend. So first thing we're going to do is we're going to figure out what X is. And we know that the tangent of 82 would be X over 45. So multiply both sides by 45 and we get X equals 45 tangent of 82 degrees. Now that's just the distance to the 86th floor. The building continues another 123 meters above that, so we're going to add 123 meters to that, and putting it in the calculator we get 443.2 meters for the height of the building. Now as far as the distance between us and our friend, the cosine of 82 is 45 over y. Now be really careful with this. It's very easy to make a mistake on this. If we multiply both sides by y and then divide by 82, that'll get y by itself. We'll have 45 over cosine of 82, which means that our straight distance between where we are and our friend is 323.34 meters. You're skiing down a mountain with a vertical height of 1250 feet. The distance from the top of the mountain to the base is 2,500 feet. What is the angle of elevation from the base to the top of the mountain? Okay, so again, draw a picture of this, draw a sketch, label it, and give it a try. Pause the recording, resume to check your answer. Okay, here's our sketch. Okay, we have a vertical height of 1,250, and the distance from the top to the base is 2,500. That's the angle there. So angle of elevation, we have the opposite and the hypotenuse, so we can use the sine. The sine of the angle is 1250 over 2,500. That reduces to 1/2. Well, what angle gives us a sine of 1/2? That would be 45 degrees or pi over 4.